Section 3.7 deals with equations that aren't necessarily functions. The unit circle is something that we use very commonly, and yet it's not a function. We're going to learn how to take the derivative so that we look at this equation in pieces. And this is going to be called implicit differentiation. If you'll notice, this is the equation for a circle. This x squared plus y squared equals 1. I can solve this for y. And when I go to take the square root of both sides, I need to remember my plus minus case that can exist. With this, you can see that the plus case is the top semicircle, and the minus case happens to be the bottom semicircle. What they're asking us to do is they're asking us to calculate the derivative by looking at just this equation here. We could take the derivative of each one of these, and we could explicitly get the function for that derivative. But let's try to use implicit differentiation because that's what they've asked us to do. So let's play this game. I am going to take the derivative of this thing right here. I'm going to take the derivative of x squared with respect to x, and I'm going to be taking the derivative of this entire thing with respect to x. So of x squared plus y squared equals 1. So here we go. Derivative of x squared is 2. Make sure this looks like an arrow here. Is 2x plus the derivative of y squared is 2y, but y might also be a function of x, so I still have to take the derivative of whatever y is multiplied by that, and that is by the chain rule. Next, I'll solve 2y times y prime equals negative 2x, and y prime equals negative 2x over 2y. 2's cancel, and the derivative of either side, the top or the bottom, is negative x over y. So we're to find the slope, and that's what the derivative is, y prime, or the slope. I want to find y prime for x equals 1/2, y equals square root of 3 over 2. So this tells me that answer is negative 1/2 the x value over the y value, which is square root of 3 over 2. Crunching this out, I get negative 1 over square root of 3. If I were to look at that point on the unit circle, 1/2 square root of 3 over 2, I would see that that tangent line is indeed negative. Let's go to the next point. X equals 1/2, y equals negative square root of 3 over 2. That would be this point down here. Plugging in, y prime equals negative 1/2 over negative square root of 3 over 2. This I get y prime equals 1 over square root of 3. Same exact slope, same exact point, although this one is a positive slope. Note that it is possible to get the derivative of the positive part and the negative part, and that would be getting the derivative explicitly, and that's okay, but not all functions can be solved in terms of y. And we'll take a look at the next one. Note that for this particular equation, I can't solve it in terms of y. So we're going to have to use implicit differentiation. So here goes. Note that that is the inside function, that xy, because it's sine of x times y. So I'm going to have to use the chain rule here. I'm going to take the derivative of the outside, leave the inside alone. The inside is this xy, so the derivative of the outside is cosine xy, leave the inside alone, times the derivative of the inside. But the inside is a product, so I will need to use the product rule. So I'll take the derivative of the first term, x, the derivative of x is a 1 times y, plus, leave the first one alone, take the derivative of the second. The derivative of y is a 1, but I also have to remember to keep in there that y prime, because y is a function of x, and there may be other things in there, and there definitely are the things in there that will have to be considered. So you'll have to leave that y prime because y hasn't had his full derivative taken yet. The derivative of x squared with respect to x is 2x, plus the derivative of y is 1 with my little y prime in there. So one of the tricks here is I'm going to go ahead and distribute this, and you're going to collect your y prime terms. So I'm distributing so that I can collect all my y prime terms together. So I'm going to move my 2x here, and I'm going to move this guy over there and this guy over there. Okay, cool trick. Factor out your y prime. Once you get used to that trick, you'll use it again and again. Then you'll just divide both sides by this juncola. Notice how sweetly that goes away. Cleaning it up, y prime is y cosine xy minus 2x all over 1 minus x cosine xy. And that would be your answer. Now I want you to notice that I could have, when I move these things over, I could have just as easily moved this term over to the other side and the y prime over. So you'll notice that sometimes somebody else's answer or the book's answer might be exactly opposite in sign of yours. And that's because you could multiply top and bottom by a -1, right? Because that is equivalent, and get 2x minus y cosine xy over x cosine xy minus 1. Same thing. So if you get this answer or you get this answer here, you have gotten exactly the same thing. So if your answer looks a little different than maybe what the book is getting, or if my math lab is counting you wrong, which it should be able to differentiate this, but if it's not, try that sign trick. Alright, I'm supposed to find the equation of the tangent line, which means I'm going to have to find the slope, which means I need y prime. Not going to be able to solve this one for y, so I'll have to use implicit differentiation. 2x plus, using the product rule for this next term, take the derivative of the first, that derivative of x is 1 times the y, plus, leave the x alone, times the derivative of y, which would just be y prime, minus 3y squared times y prime equals 0. Collect your y prime terms on one side and anything else on the other. So 2x plus y equals 3y squared y prime minus x y prime. So just moving these two guys over to the other side. factor out my y prime, trick we learned last time. Dividing both sides by the juncola that's over there with that y prime. You now have what y prime equals, because that guy cancels. So here's my derivative. Then they didn't ask me for the derivative, but I had to get the derivative because they want the equation of the tangent line. So this is going to get me slope. So I'm going to need the slope. Here's my point. The slope at that particular point, and that point is x equal 3, y equal 2. That slope is 2 times 3 plus whatever the y is, that's 2, over 3 times 2 squared minus 3. Cranking those numbers out, 6 plus 2 over 12 minus 3. That's going to be 8 over 9. Okay, great. That's my slope. M equals 8 over 9. They couldn't give me a prettier number. And my point is 3, 2. So the equation for a line is y minus y1 is m times x minus x1. There's your point. There's your slope. Here's your point. Plug it in. Y minus 2 equals 8 over 9. Great. X minus 3. And then I'm going to manipulate this thing just a little bit. Y equals 8/9 x minus, multiplying this would be 8 over 3 plus 2. Getting a common denominator, y equals 8/9 x minus, this would be 6 over 3, so minus 2/3. That is the equation of the tangent line. It's the equation of this line, equation of the tangent line at that point. They're asking me for y double prime, so I guess I better find y prime first. I think I've already done this one, but I'll do it again. 2x plus 2y, y prime equals 0. Y prime equals, move your 2x over, divide by 2y. Y prime equals negative x over y. Okay. Y double prime. Y double prime equals, I need to take the derivative of this thing, which means I'm going to need to use the quotient rule. The quotient rule says I need to do low times the derivative of the high one, so times -1, minus the high one, that's negative x, the derivative of the low one, which is 1 times y prime, all over y squared. Okay. I know that y, I don't want a y prime in my y double prime, and I know that y prime is x over y, so I'll clean this up a little bit and then I'm going to do a little substitution. Y double prime equals minus y, that's a plus x y prime all over y squared. This is going to be negative y plus x times negative x over y all over y squared. Still not too pretty. Let's clean it up even further. Oh, that should be, oh yeah, okay. Negative y, and then minus x squared over y all over y squared. How about in order to get this fraction out of there, I multiply top and bottom, say, by y. So let's multiply top and bottom by y over y so that I can make it even cleaner. And this is going to be y times that, minus y squared minus x squared over y cubed. Hey, that does look prettier, doesn't it? Always trying to make my answers look nice. Oh, wait. I see that x squared plus y squared equals 1. I can make it even prettier. Hold on just a minute. So if I pull out a negative here, I'll get x squared plus y squared. Ooh, I'm too excited. X squared plus y squared all over y cubed. And this guy is a 1. I've got negative 1 over y cubed. Now, doesn't that look nice? That is even better. Ah, nice. Example 5, we're using the power rule for rational exponents. So I'll write this as y equals x to the 1/2. Kind of been using this anyway. Y prime is, bring down your power, 1/2. X to the 1/2 minus 1 is negative 1/2. Cleaning it up, y prime equals, this negative exponent means it's in the denominator, 1 over 2 square root x. All done with that one. Play this one. This one involves the chain rule. Y prime equals, where this is the inside function, 2/3, leave the inside function alone, 2/3 minus 1, here's your 4th grade work for you, would be 2/3 minus 3 over 3. That would be a negative 1/3. Alright, so I use the chain rule. Take the derivative of the outside, leave the inside alone, times the derivative of the inside. The derivative of the inside is 6x to the 5th plus 3. Cleaning this up, 2 times 6x to the 5th plus 3 over 3 cube root, oh, they left it, well, I don't have to write it. Probably should leave it in fractional exponent. Hold on. I wanted to write cube root, but seeing as they give it to you with a fractional exponent, you really should leave your answer in the same terms that it was given. So x to the 6 plus 3x to the 1/3. However, you never want to leave anything with a negative exponent. You could multiply this 2 out if you want, but this is about as pretty as it gets. It's ugly. I guess after looking at it, I could take this 3 out of here and cancel it out of the bottom. Alright, let's do it. Some of these, you look at them and then you go, oh, wait a minute, I could still do this. Alright, my 3's cancel. Now, I could multiply that 2 through there if you want. Either way, it doesn't do anything. You can, don't have to. Whichever way you left it on that would be fine. I do like that 3 out of there, though. It makes it a little prettier. Okay. Find the slope of the curve. I guess that means I need to find y prime. So I've got 2 times x plus y to the 1/3 equals y. This is a bit messy here. It involves the chain rule. Here we go. I'm going to take the derivative of the outside. Here's the inside. The outside is the something to the 1/3. So that'll be 2 times that 1/3. Leave the inside alone, x plus y. And then this is going to be to the 1/3 minus 1, or minus 3/3 is minus 2/3, times the derivative of the inside. The derivative of the inside would be 1 plus y prime. Okay, not liking that, really, equals y prime. I'm going to need to distribute. I'm going to have 2/3 times x plus y to the negative 2/3 times the 1 plus 2/3 times x plus y to the negative 2/3 times y prime equals y prime. Same game, move that term over and then just sit here and mess around with some ugly algebra here. Y prime minus 2/3. And yeah, you guessed it, I am going to factor out y prime. It's the whole reason I did it. And then I'm going to divide. Okay, now divide by this monstrosity. And then on the other side, it takes forever to write this stuff down. And then you got to make sure you don't make any stupid mistakes while you're doing it. Ka-chunk, you're out of there. Okay. So y prime equals, and I'll write it down again, and I'm going to write it as, see, that actually belongs in the denominator. What a mess this is. Getting rid of that negative exponent because it is so messy. Not that this looks stunning, but it looks a little better. So here's my main fraction. You know, not that it really matters because all I need is the slope, so this really doesn't matter, but just so that you can see it, I could make this prettier by multiplying top and bottom by 3 times x plus y to the 2/3. And if I do that, then I'll get, you know, it'll cancel here, and then I'll have to distribute, so it'll multiply on this one and it cancel on this one. So what I'll have is 2 over 3 times x plus y to the 2/3 minus 2. And that looks so much better. Not that I really had to do any of that, because what I really want is the slope. So I want the slope at the point x equal 4, y equal 4. So I want y prime at 4, 4. So I'm going to plug in x equal 4, y equal 4, and then just crunch out the number. So the slope is 2 over 3 times 4 plus 4 to the 2/3 minus 2. It's going to be 2 over 3 times 8 to the 2/3 minus 2. 8 to the 2/3, well, I take the cubed root of 8, which is 2, and then square it, and that'd be a 4. So this is going to be 2 over 3 times 4 minus 2. Be 2 over 12 minus 2. 2 over 10. And I did it. It's a fifth. And I'm done with this section. And if you have any questions about it, be sure and email or come see me at the Collaborate. Oh yeah, I thought I'd mention that the slope of this line, that they wanted it at 4, 4. So the slope of the line at 4, 4 happens to be slope of the tangent line. Whoops, that's really bad. Tangent line. Slope of that tangent line is 1/5 if I could draw it straight. Okay,